Good evening, everyone. Today we are here to discuss cannizzaro reaction, which is one of the most favorite reaction and commonly asked in your exams. This belongs to a chapter aldehyde ketone given in your book, and most of the time it become a part of exam, no matter which exam we are talking about. So without wasting much time, we are going to start this reaction, cannizzaro reaction. This is a reaction which is shown by those aldehydes which do not contain alpha hydrogen. In presence of alkali, when such aldehydes are heated, they undergo redox reaction. Cannizzaro reaction is also an example of disproportionation because this reaction takes place in such a way that oxidation and reduction of same substance take place. For example, when we consider formaldehyde, which do not contain any alpha hydrogen, undergo this reaction, it forms a pair of compound, methanol and potassium salt of formic acid. The remarkable thing is that this reaction always takes place for those aldehydes which do not contain any alpha hydrogen. When we talk about disproportionation reaction, we must understand that oxidation and reduction together take place. Suppose a aldehyde which contains CHO group and the carbon present on its alpha position is called alpha carbon. The hydrogen attached to it is called as alpha hydrogen, and this has to be absent. This is the necessary condition for this reaction. So we can have a mechanism to oxidation and reduction of aldehyde group take place. We can again write the reaction like in molecular formula. Two molecules of HCHO are converted to methanol and potassium formate. Here if we consider oxidation and reduction, so first group C double bond O, which is also called as carbonyl group, is reduced. There exists reduction, and in reduction what happens? The CO bond is broken into single bond and the two different valencies are satisfied by hydrogen atom of carbon and oxygen respectively. This process is called reduction. On the other hand, oxidation of aldehyde group take place, and during oxidation CH bond of aldehyde get oxidized to COOH. Due to the presence of base, it converts into its salt. That's why we have reported potassium formate in place of formic acid. We can proceed via mechanism. It involves following steps. Like in the first step, when KOH ionizes to produce OH minus ion that act like a nucleophile, and the OH minus attack on carbonyl carbon to form a addition product. After this step, the last and the most important step comes where a hydride shift is recorded. Due to the shifting of hydride, another molecule of formaldehyde get reduced and the formation of a base take place which absorbs proton from the acid and form acid salt and alcohol. When we talk about the other examples, so other examples can also be represented like this. And when we talk about benzaldehyde is converted into benzyl alcohol and sodium benzoate. Let's move to the next reaction, which is cross cannizzaro. This is a part of it. Remarkably, a cross cannizzaro reaction is only considered as redox. It is not a disproportionation reaction. The reason is because oxidation and reduction of different aldehyde groups take place. I want to mention here that two different aldehydes, both without alpha hydrogen, are capable to show cross cannizzaro reaction. Right? Both must not bear any of alpha hydrogen. Like in this reaction, when benzaldehyde and formaldehyde both are taken together, oxidation of formaldehyde is much easy, and that's why the formaldehyde get oxidized to form acid salt. In fact, acid, due to the presence of base, is converted into salt, and benzaldehyde get reduced. The CH bond strength of benzaldehyde is larger, that's why it does not oxidize as quickly, so prefer to get reduced. When we talk about this reaction, that can be directly written in terms of molecular formula like this: formation of benzyl alcohol and potassium formate. One important statement I want to quote here, that in this reaction no change in the number of carbon atom take place. Let's move to the next, which is intramolecular cannizzaro reaction. Such kind of cannizzaro reaction is again a redox, not disproportionation. The reason is that oxidation and reduction of two different aldehyde group, both without alpha hydrogen, take place, but they both are present in the same molecule. That's why it is called intramolecular cannizzaro. Here glyoxal is taken, and after reduction it converted to CH2OH, and on oxidation it convert to COO minus like previous one, and here I am marking that oxidation and reduction together. A few examples. The same can be studied in this compound where benzene contains 2 CHO group on ortho position. Now a practice question is there. Try to approach this. In the first question, you can see that both aldehyde group, one aldehyde and one ketonic group, do not contain any alpha hydrogen. And because of that, the ketonic group get reduced and aldehyde group get oxidized. Nice. And when we talk about the next example, we can conclude that there is another compound having no alpha hydrogen, this undergo disproportionation and CHO group reduced to CH2OH and oxidized to COOH. Due to the presence of NaOH, the sodium salt is being reported. Let's move to the memorable points. Aldehyde without alpha hydrogen undergo redox reaction on heating in presence of concentrated alkali. This is cannizzaro reaction. Oxidation and reduction of aldehydic group is observed in product. Number of carbon atom in this reaction always remains same.